capital city of the Philippines. The purpose of the ferry is to transport up to 100 passengers, along with their bicycles, strollers, and the luggage. Additional area for the disabled people should also be included. And the vessel, because the passage river is very specific, it will faces numerous challenges. Different water wave condition, diverse weather patterns, bicycles, strollers. Also the need for the cost-effective construction, operation, maintenance, and the repair has to be taken into account. And the design must comply with IMO regulations and the national regulations of the Philippines. Typically, vessels are designed according to their cargo. And in our case, as I said, our cargo includes the passengers, which means the ferry should ensure a comfortable and suitable experience. And now we are talking here about the electric ferry, which means we have to take into account additional safety measures beyond traditional ferries. Depending on the electrical components, what you will choose, it's also necessary to address the specific problems and to find a way to mitigate and to manage them. Also, very briefly, something about the river and the operation. The vessel should operate between the three floating, three floating pontoon station, which also include the shore side infrastructure for the charging. The duration of the journey should be projected to be less than the 1 hour, which is also 1 hour less than the road trip. And that was also the main requirement of the competition, just to be more efficient than using the car and the bus. Also, about the river something, it's 25 kilometer long approximately, and it's crossed 90 bridges. Fast currents, tidal variation, as well as depth, they're just, let's say, some of the things what we should also consider in the design stage, and also for the selection of the engine. This means in general for those requirements, if they ask for something, we had to respond on something. But we had to prioritize the safety, affordability, and sustainability, keeping the certain speed, because, as I mentioned, we are limited with the time. I would also like to say that one of the requirements in the way of the submission, we had to send the 18 pages of the report and specific drawings and analysis, and the 5 minutes of the presentation, what you will see after. And from my point of view, I would like to mention this was the most difficult task for us, because you had to pack everything in this report and the presentation. And that's the work of the 5-6 months of the 5 people. This is just very brief requirements. And the guys, they will talk more specifically about the design. We pointed out some topic what we thought it will be interesting for you. I think, Mads, now it's your turn.
Mars is having connectivity issues, so I will describe everything regarding CFD and the hull design. So as Marco told, after we laid out the groundwork for the preliminary requirements, go up to the previous slide. Marco. So as then we started the hull design process, while Mahmoud and others were looking for the general arrangement and safety requirements and electrical requirements. We started the hull design process also concurrently. So first we modeled a very rough hull shape using Rhinoceros 3D and carried out CFD simulations with a validated OpenFOAM setup. So as you can see on this red line picture, the preliminary hull is having a chin and kind of a square shape. But after the CFD simulation on this primary hull, we figured out that the resistance experienced by the hull, as well as the wave profile omitted by the hull is not so optimal. The resistance was very high and the wave profile was very tall. We had to reduce it because we have to consider the safety of passengers as well as the vessels sailing nearby us. This is a very narrow river. And for the economic reasons, we had to reduce the resistance also. So we decided to optimize the hull. Then following that, we redefine our primary hull as a parametric model. Parametric model as in a setup, as in a system defined, geometric system defined by set of mathematical equations, and all these equations are interconnected. Then we ran an optimization algorithm with the main goal of reducing the resistance. We use this software called Cases, which is a very capable software. Modern naval architects are using in the industry as well as in the research field. So while running the algorithm, and at the end, we came up with this blue hull shape. And as you can see, the blue hull shape, it doesn't have any chin, and it's also very smoothed out. It has a slight, significantly curvy shape compared to our primary hull. Marco, if you click once more, they will see the optimization process. No, the videos are not playing. Maybe you can play the videos manually. Okay. Anyway, you can see.
Maybe they can see after on the video.
Yes. Yeah, on the video. So compared to the first picture, second picture has a reduced wave profile, and we managed to reduce the resistance experienced by the hull by 15%. So it was a significant improvement. Then we can go to the next slide. So one more thing that makes our design distinguish in this detailed power analysis, I think you already know that after a certain limit, when the water depth is decreased, the ship resistance also goes up exponentially. So this is called the shallow water effect. Our Pasig River is already shallow, and we found out that the water level is varying continuously because of the tidal currents. In that case, we had to consider the river depth also in our powering analysis, and we approximated the river depth variation, as you can see in this blue and gold graph. Then we carried out separate CFD simulations for each journey of the boat, and then you can see in this step graph how we modeled and how we finalized the power requirement curve. So this curve is more capable of approximating the battery sizing and the motors and other powering components compared to someone who just get the average power per journey and multiplying that by number of journeys per day. So that's not very accurate because our the resistance experienced by the ship varies time to time. And this tiltable propeller is also one of our highlighting points, because Pasig River, we found from the requirements that Pasig River is slightly polluted and it's an urban river. So there are a lot of trash and overgrown floating around. So what happens if the propeller get caught in some of the trashes and it gets stuck? So the operator has to dry dock the vessel. But with this design, we can operators can just tilt up the vessel, sorry, not the vessel, the propeller, and just clean the stuck trash or anything without the need of expensive dry docking. So this is about the propeller power analysis and the hull design optimization. Then I think Abhiram can discuss about the electrical part.
Yeah, sure, Ravindu. So as explained by Ravindu, we did a year-round propulsion power analysis considering the seasonal variations and the river current tidal variations. So with that, we could arrive at a an optimized propulsion power requirement. So to design the electrical system efficiently, what we considered is that we considered 4 different operational conditions. So say the sailing, cruising, berthing, and emergency conditions. And we used the maximum propulsion power, that we got from our year-round analysis, and we added with the hotel loads that was required in all the 4 operational conditions. And we considered the maximum power requirement in those 4 operational conditions. And with that, we could see that the powering condition required the maximum power requirement, which was around 320 kilowatt hours. So we had to select our battery to meet that requirement for a round trip. That was our criteria. Considering so a battery have a depth of discharge, so which is needed to extend the life of the battery. So we considered a depth of discharge of 80%, so and a usable capacity of 90%. So considering those 2 factors of selecting a battery, we could come up with a propulsion power of 391 kilowatt hour, which was required for a round trip. So considering that power in mind, we selected our battery, the Toshiba SCIB battery, which is what we selected, which is a titanium oxide battery. And we had to select a number of 364 modules to meet our power requirement. So we divided this to 364 in the 2 hulls of our catamaran vessel, which could sufficiently meet the which can split the weight equally into the 2 hulls. So our selected battery could give a total discharge and charging cycle of around 20,000 cycles, which was equivalent to have a lifespan of 6 years. So which is actually a good number in case of a battery selection. And the most important criteria which we looked at selecting the Toshiba battery is that it's quick charging time. So it was the battery could charge, the 80% of the battery could charge in a mere 6 minutes. So this was one of the requirements that we had to meet, the quick charging capacity of the battery. Considering this quick charging in our mind, we selected our charging system. So in order to charge this battery in 6 minutes, so we needed a current capacity of 14,000 amps around. So considering this in mind, we selected our charging system. So we had 2 different types of charging methods. Opportunity charging, which is the charging during the embarkation and disembarkation of the passengers. So the small interval, in which we need high current output to charge the battery in 6 minutes, and the destination charge, which is the charging of the battery in its base spot overnight. So which doesn't require much current capacity to charge the battery. So we consider all this in mind while selecting the shore charging system. So another idea that we proposed in our design is the battery swapping possibility. So which is that an additional battery modules which can be charged onshore can be replaced with the drained out battery in our vessel. So which can also reduce the charging period at each spot. So this is one of the idea that we proposed in our design. So apart from these energy storage system and energy supplying system, we had 60 solar panels embedded in our vessel, covering an area of around 200 square meter above the passenger seating area. So which could actually generate a current capacity of around up to 180 kilowatt hour, which depends on actually the season. So in summer season, it can generate more power, and winter and monsoon season, it may generate lesser power. So it, considering our calculation, it can meet up to 16 to 14% of the hotel loads of the vessel in different conditions. So this is one of peculiarity of our design. And we also had a standby generator, a variable driven standby generator, so which can actually meet our emergency condition. So the power requirement in that, we selected the variable drive generator in such a way that it meet our emergency condition in the case where all the other power supplies are failed. So these are the electrical system selection these are the systems that we did to select our electrical system. And moving on from there, I think Mas will take over. So, sorry, Ravindra.
Just unmute yourself.
Okay, sorry. So our discussion was very short and brief, but like our Cloverleaf was done at this point. So we carried out life cycle analysis. Then we compared the operational carbon emissions and the operational fuel costs of our vessel, of our Cloverleaf, to a traditional diesel-driven vessel. Then we figured out that Cloverleaf has 45% less carbon emission potential, and also it's significantly lesser in cost incurred in the operational phase when it comes to fuel costs. So I used this. I left this slide here just to tell you that. Our design was already done, but adding this adding this kind of high-level analysis will add a depth and value to any of your work. So if somebody wants to learn these kind of things, life cycle analysis, what is life cycle analysis, what happens with the tidal variation, these kind of things, it'll make your designs and your projects look more serious, and it'll add more value. So if someone wants to learn, there are many free softwares in the internet. For example, this life cycle analysis, it was carried out in OpenLCA, which is total complete open source software. So if someone wants to learn, they can learn. I think our slideshow is done from here, right? Then we are going to the video.
Yeah. I will play the video now. Just Tadea, let me know if you can hear the sound.
Just know that your work can be good, but you should be able to present your work in a very good manner also. It should catch the eyes of the visitors and all the spectators. So our video, we put some effort into our video also, promotional video. You can see that.
I cannot hear the voice. I don't know if it's the case for everyone.
Yeah, I also cannot hear the video, the sound.
I don't know if you are you showing the video? I see the slides.
But you cannot hear the sound?
No.
Just a second. Hold on. Okay. Now.
No.
You cannot?
No, I cannot.
No.
Just a second. Maybe just to turn it on. Sorry, guys.
Using a parametric model driven by various design parameters such as
now we can hear.
between hulls.
Now you can hear.
Form thousands of potential.
Okay, I will play from beginning. This just, by the way, this was the video what we submit for competition. Some things they will repeat it, and you can also find the video on YouTube.
Greetings. It is with great pleasure that we from the University of Rostock unveil our preliminary design of the signature 4-globe leaf symbolizes the uniqueness, safety, efficiency, and sustainability of our design. The clover leaf has been specifically tailored for the Pasig River in Manila, Philippines. It will voyage between Guadalupe and Lawton areas under 60 minutes, which is a huge merit over road traffic. Passengers can bring their bicycles on board and even charge them. Wheelchair access is also enabled. The Cloverleaf's hull is crafted through a rigorous optimization process. Using a parametric model driven by various design parameters such as length, beam, distance between hulls, and hull form, thousands of potential designs were generated. Finalized hull exhibits a significant reduction in wake and resistance, resulting in outstanding performance. The meticulously developed arrangement ensures a pleasant and comfortable transportation experience for passengers and easy operability for the crew. The sleek low superstructure prevents collisions with bridges. The low draft ensures safe operation regardless of fluctuating water depths caused by tidal changes. Cloverleaf fully complies with DNV and IMO rules. The use of an aluminum structure not only offers economic benefits, but also allows for the vessel to be fully produced at a local shipyard, supporting the community and fostering local growth. The intact and damaged stability were investigated with different loading conditions, and all the results validated the safety of the ferry. To ensure optimal performance, a comprehensive year-round power analysis was conducted, considering weather patterns and tidal variations. This analysis enabled accurate sizing of the propulsion system on the Cloverleaf, resulting in greater efficiency and cost savings. The modern, stern-mounted, 360-degree propellers provide exceptional maneuverability, allowing quick and easy navigation in tight spaces. Additionally, the propellers can be tilted upwards, making it easier to clean. This reduces the need for dry docking and ultimately bring down maintenance costs. The advanced electrical system sustains 2 hours of uninterrupted sailing. Battery can be charged up to 80% within mere 6 minutes. Roof-mounted solar panels can contribute to up to 40% hotel loads daily. Optimally sized generator ensures continued operation in emergencies. The ferry is equipped with advanced systems to detect, prevent, and combat fires, all of which are designed and built to meet uncompromised SOLAS standards. The battery room and the passenger spaces, the main 2 areas of concern on board, are isolated from each other with H60 watertight doors, according to SOLAS regulations. Additionally, heat and smoke detectors have been installed in the battery room for early detection of potential fires. Temperature monitoring is done through the battery management system. The ultimate safety measure of the Cloverleaf will be its automatically triggered water-based firefighting systems, which not only extinguish any fire but also cool down the batteries in the process. In potential future pandemic situations, the HVAC system on board will ensure sufficient air circulation through the passenger space. The spacious accommodation would allow enough distancing once the onboard passenger limit is reduced to 60 persons. The engineering behind Cloverleaf is constantly evolving, incorporating the latest data analysis techniques. By gathering a wealth of operational data, the vessel's digital twin is able to generate highly efficient route plans, power forecasts, and passenger predictions. As we continue to gather insights, the next generation of Cloverleaf will push the boundaries of innovation even further. From the outset, the Cloverleaf has been designed with affordability in mind. Despite its modern features and advanced engineering, the vessel offers a rapid return on investment with a payback period of just 5 years. This makes it an attractive option for fleet operators. The affordability does not compromise the other main drivers of the ferry by the least. The vessel is so efficient that it can save a whopping 59% of fuel costs compared to a fully diesel vessel of the same size. The carbon emissions at the operational stage would be reduced by 34%. Thank you for your attention. We invite you to hold on for a short promotional video.
Los cálculos son buenos, pero si ven ustedes la potencia de poder vender es
I would just like to add a few more sentences, and mainly, I don't know if there are some professors, but I'm referring to the students. Probably you forgot everything what we said, but I hope one of you gets interest in this competition, and that was the goal of this presentation. Our advice to you: try to find the people with the same energy and desire for this. Organize yourself, act as a company, split the work, and push yourself. As outcome of this, you will learn from each other for sure. And if you win, let's say one of the first 3 places, you will get the money prize, and you will be invited in the New York for the conference like us. You will get the opportunity, from my point of view, you will get the opportunity to present your country, your university, and yourself. I think we stay in the New York 4 days. We explore the city, we ate good food, and we got to ride with the ferries. And from my point of view, I think we don't need to say anything more. We are open for the questions, and if you're too shy to ask something, please contact us or Tadea, and we can provide you additional information about this competition. Gracias.
Thank you so much. Thank you so much. And again, guys, congratulations. Here, Professor Marin, I'm sure he will ask some questions.
Oh, congratulations. That's a great job. One of the things that we try to teach our students is how to work as a group, as a team. Would you please give us some advice on how to organize, how to select the members of the team, how you organize the work so everybody has the same amount of load and things like that? Especially, how many hours did you have to spend to complete this project?
Mahmoud, do you want to answer, or?
Yes. I mean, in our case, we had like 1 year studying together in Liège, so we know each other in a good matter. And when we decided to go for the competition, I asked everyone if you are willing to do this. If you want to join this competition, we will have to do something unique. That means that we will have to do something more than what University of Rostock needs, because in the first semester in University of Rostock, we have designed a team project as a part of our syllabus. And in the same time, it will be also the same design that we are submitting for the competition. But if it's only University of Rostock, so we can do anything and we will pass. But if we want to win the competition and it's a worldwide competition, we need to do something special. So I like personally, I know everyone who participated in this. As I said, we studied together for 1 year. We stayed at night studying, drinking coffees, talking about anything. So we had a very good relation in a personal level. So when we started the design, we organized it in a way that everyone will do the thing that he's enjoying doing it, because if you are doing the job just as a task, you will not perform that much. So for me personally, I like the structural design. This is my field of expertise, and I know I know a little bit about rendering, and I am very interested to do something about rendering and all this animation. So I also volunteered to do this task. I know by heart that Ravindo, he is the life cycle guy, and he is the guy who's interested about all this stuff. And also he and Maz, they did a very good job in the CFD, because like they already have some experience about CFD, so it will not be that much issue for them. Marco, he did his best in everything. Like he was accepting our modification, because as we all know that the designing a theory is a spiral process. It's a loop. So in one night, I just came to him. Okay, we had to change the draft. We changed the draft, so you have to recalculate the stability again and everything again, the damage, the intact. He enjoyed doing this. He was enjoying this. Also, Abiram, he did the electrical part. So the thing is, I was the team leader, but I didn't feel that it's something unique. Like we all did the same amount of work. Everyone volunteered to do this task. We made a spreadsheet and we put all the tasks that we want to do. And then I said, okay, let's pick what he want to do. And everyone pick the thing that he like to do and he can perform in doing it, not only doing it, but doing it in a good way. So it was total like personal choice. If someone chooses to do something by his heart, he will do it better than just doing it as a task.
Yeah, and I would maybe add something more. I think it's quite important to have the captain, to have the team leader. You cannot say that, I can say. Because he will push you. He will give you a work. And just the organization, I think the organization it's quite important. That is the reason why I said I think if one of you is interested about this, just find the people who are willing to apply for this, because I think it's really worth it. Now we are presenting at the University of like in Ecuador. It's like, who would imagine? We were in the New York. Like it's really, how to say, I don't know, as a student, it's really good feeling. You did something. We did something.
It also will add some value to your resume when you say that you participated in a worldwide competition for designing a theory and you got the second prize or the third prize. It's doesn't matter in this case, but like you participated and you won, you get at least one of the first 3 positions. It will add some value, add some weight to your resume. It will help you afterward in your career.
Yeah.
Thank you very much.
Yes, thank you so much. Please, you have here some bullying about your accent.
¿Alguna otra pregunta que quieran hacer? Yo podría traducir si desean, o ella puede.
Yes, guys, thank you so much for your time and for the presentation. Again, congratulations. Here we all are awesome about your work. So it was also good to see you again, and please stay in contact.
Okay,
so,
yeah, sure.
Muchas gracias. Thank you so much, guys.
Thank you.
Bye.
You're welcome.
Bye.
Bye. Good luck. Bye.
Good luck, guys. Bye-bye.
Yep, good luck.
Solamente un comentario. Ustedes escucharon al final